Welcome everybody. Today what we're going to do is remanufacture a version of the original Tesla turbine that I showed you how to make a few years ago. The original design was built from a stepper motor. Today I'm over at a friend of mine's 3D print farm and we're going to remanufacture a version of that Tesla turbine as close to that as we possibly can out of modeling grade materials. Once we get the model up to par and basically you can see that all the tolerances are correct and everything functions, we'll put the G-code into a much higher grade machine. We're actually going to print another version of this out of a material called Ultem 1010, and potentially if that doesn't work we'll even print one out of a material called Peak. Both of those materials are a aerospace grade, very high strength and also high heat resistance 3D printing material. Hopefully we can get everything right and we don't have to build this too many times out of the modeling materials, and we can get right onto those high strength materials. For today's show, what I'm going to do is take you along as we print out the very first one of these working models. We're going to test out that working model and see just how well it works. Let me go ahead and move this image around for you a little bit so you can see that I've tried to replicate the rotor blades that I created out of the original stators inside of that stepper motor. I've recreated even the outside little notches on the blades. Let me go ahead and zoom in for you a little bit so you can get a better image at those. See, I've even recreated the teeth that were in between the original rotor and the outside stator blades that we hooked together with a little Carter pen. I've got the notches in the outside of the blade, a very similar pattern cut out on the insides of each one of those rotors. So let me go ahead and zoom back out for you here. And there you go. So there's the entire build. We've got spacers right here. They're going to actually create the space between each one of these rotor blades. So we've got enough of those ready to go. We've got the case over here. If I change the angle, you can see just how deep that case is. Up here at the top of the case, we've got input holes on both that side and over here on this side. Let me go ahead and zoom in on those so you can take a look at the input holes and how they work. Go ahead and move that over here so you can see it. Alright, so those are the input holes right there, those 4 holes. And we'll go look inside of the case here. And you can see right here are the input holes coming into the case. So I've got input holes coming from this direction so we can spin it one direction. And then I've also got them coming in the opposite direction so we can reverse the direction of spin. We've got 4 different holes so we can actually increase or decrease the amount of power going into the turbine based on how much actual air or steam or whatever we're actually using to fuel this. Let's go ahead and zoom back out for you here. Sorry, it's a little hard to do. I don't have the mouse going, just using the keypad here. So there you go. We've got 12 rotor blades. We've got the 12 separator discs that we're going to use to separate the rotor blades. We've got a case. I don't have any room left on the build plate here to build the top and the bottom cover to the case. We're going to have to go ahead and do that on a separate print, and I'll show you that. But if you stay tuned here, what we're going to do now is I'm waiting for one of his printers to get done working, and once it's done, we're going to load this file into that printer, and as it prints this out, I'll get some film of it and put it together kind of as a time lapse so you can see the build process take place. Once we're done building the turbine, install a steel drive rod down the middle of each one of those rotor discs. We'll put some bearings in there. We'll attach that all together in the case, and we'll actually give this little prototype a test spin with some air pressure and see just how well it works.
there you go, guys. Our first large disc for the much larger Tesla turbine is finally done printing. We're going to go ahead and print out 11 more of those. Alright guys, so here's the case printing. Because it took so long to print and this isn't my place, I had to go home. Wasn't able to get a time lapse of this printing. Just came back, it's 9 o'clock here in the morning. And we've got about an hour and 5 minutes left on the print. And that's what it looks like. You can see the air inlets right there. I'll show you guys what it looks like when it's done. Alright, there we go. That is the back cover to our Tesla turbine. Completely printed. I've got to let it sit for about 20 minutes or so and cool down. It'll pop itself loose from the build plate. And then we'll start printing the front plate that has the output holes. And once that's done, all we've got left to do is print the spacers and the rest of these rotor blades. Right now we've got 5 of them. There's a 6th one printing at the moment. We have the case ready to go. Looks like a pretty good size. It's even bigger than the original. Alright, so our output cover is ready to go. I think it's cooled down enough. Oh, look how easily that came off the build plate. Looks like there's a little stringing inside the bearing cup, but other than that, the print looks like it turned out pretty good. Here's our first batch of spacers that go between our rotors, giving us the space we need. Alright guys, so we've got all of our pieces back at home. They're all printed and ready to go. We're going to start assembling our Tesla turbine today. And I'm going to first dry assemble it and lock it all into place with some keeper wire. Put it into the case dry, give it a spin, make sure everything looks right. And then I'm going to glue it together with some super glue. And as we build it, we'll be making sure that each one of these outside little grooves that you see here, these outside little notches, are stepped just slightly off from the next. And that way it does the exact same kind of stair-stepper style effect that we had in the original Tesla turbine design. Real quick, let me just kind of show you all the parts. We've got the output side of the turbine right here. You can see all the output holes. And because we're going to be using water for this, I have a feeling I'm going to end up having to either remake one of these with quite a few more holes than this one has, just to let the water out without actually backing up in the system at all. We may just drill into this one. We'll see what's going on with that as we get there. Over here we have the case in the back cover plate ready to go. I've just got it in place there so I can use it to build off of. I'm actually going to set it down just like this. We're going to take the drive rod piece there, we're going to set it on that just like that, and I'm going to start stacking the rotors on top of each one of the spacers. I'm going to step them all off, and then we're going to use a little piece of this PLA wire that we've got right here. I'm going to stick that down through the little holes that you see in the center right here. We're going to lock all of those together as we build it and make sure it looks right, and put that together dry with these little wires, and I'll show you that as I'm going. Okay, so we're ready to start building. I've already got the initial rotor and a little spacer on there. Hopefully you can see that. What we need to do now is line this all up and keep that spiraling staircase look to it as we build. So let's go ahead and grab a rotor. We're going to slide that down over the shaft here. Could take a little bit of pressure to get this started. There we go. Okay, so we've brought it all the way down. We've got them ready to go. I now need to start offsetting that bottom edge, and you can see that's way off, so we're going to need to bring it over to somewhere right about like this. Hopefully I can get that in the camera for you. Line up. Now you see these rotor teeth are starting to line up right here, and that's what I'm actually looking for originally, is I'm going to try to line those up as we step through this, and that'll allow me to get that stepped look, and then I'll go through and line up the spacers and the holes in the spacers. Alright, so we've got another spacer here, and this is definitely a little bit of a chore to get these things started. Once they get started, they go down pretty well. There we go. We now have 2 rotors and 2 spacers. They'll start getting much closer together. Let me go ahead and push them together and give you an idea of what it'll look like. So there you go. Let's go ahead and start adding another rotor. Boy, that's not easy to get down on there. I don't want to break them. Okay, there we go. And one more of these spacers. And there we go. Let's go ahead and feed on another rotor. Alright guys, so the next step of this is to make sure, before we glue this all together, that this fits inside of our case right. Looks like everything's going to be centered okay. Let's go ahead and try to dry set that and make sure it's good, and then we'll put this thing together and give it a good spin up. See how well our homemade Tesla turbine works. I've got the whole thing assembled. We've got the rotors there on the plastic rotor shaft right now. I printed out a couple plastic bushings and stuck them inside of it just so we could give it a spin to see if the clearances are good, to see if everything centers right. I've got some pieces of copper wire I've stuck all the way through the entire body. These are hollow, and I bent them over on either side just to hold our case together, and the lid's on there, so as you can see there. I put a little piece of white paper and some tape on the rotor so when I spin it you can actually see it spin. And right now that's just plastic on plastic bushings. That wouldn't work if we were using this with compressed air. The heat generated by that plastic on plastic friction would definitely melt itself together and lock this thing up or melt down the drive shaft. But because we're actually testing this out originally with really cold, high pressure water, I don't think we're going to have an issue giving it its first primary test.